Thought I would talk a little bit about landfills for a minute as kind of an introduction. Basically, what landfills are is they're the garbage can of everything that we throw away. Over the years, they were very hazardous and nobody wanted to live next to one. Beginning in about the early 1990s, the EPA, Environmental Protection Agency, put on various restrictions that basically said that the landfills had to have a liner underneath them, and if they were going to collect more than 2.5 million tons of waste, they had to have installed a methane burning or a landfill gas flare to mitigate the odors from the landfill, as well as to make sure that methane did not migrate around the landfill. Methane is poisonous. It can kill if it's of a sufficient concentration. So they did that. EPA did that, and all of your state environmental groups echoed exactly what the EPA put down. They also required that leachate, which is the water that is produced by the decomposition of the waste, had to be collected and to remove it. One of the things that the old days, it used to be put in what they called evaporation ponds. Now it has to be treated by a sewage treatment plant or a wastewater treatment plant. Basically, your chemistry was your formation of your carbohydrates, anaerobic decomposition, or taking the carbohydrates, adding a bacteria to them, letting them decompose into methane, CO2, and heat. As a landfill decomposes, it generates heat. It can get up to 120, 130, 140 degrees. It is a phenomenon that we're starting to see, that the more water that there is in the waste, the faster it decomposes. But it also risks the hazard of having underground fires, or as the engineers and safety people call it, subterranean combustion. So the decomposition of anything that has carbon, whether it is paper, whether it is wood, virtually anything that will decompose is in the landfills. The sewage treatment plants are significant sources of methane, and the biodigesters at the sewage treatment plants are now required to collect the methane since about 4 years ago. That's why when you travel now, you don't really smell the landfills, nor do you smell the sewage treatment plants as you used to. Before I get into some of the equivalents, basically what happens is, when the practice of the landfills today is everything that is received is buried. It has to be covered by earth every night. If you look at the big landfill that is down off of 5570 at the Granite City exit, you will see that tremendous mound of trash. What happens basically is that as that decomposes, it decomposes into some other fine contaminants. Besides the methane and besides the CO2. And those could be siloxanes, which is a sand type of a residue. It could be sulfur, it could be hydrogen sulfide, It could be a number of other contaminants. Because the landfill decomposes at different rates and the trash decomposes all over in the landfill, it is very, very difficult to get a reading of what the gas today is going to be or what the gas tomorrow is going to be. So initially, when the gas was collected and instead of being flared, it could be piped over to a industrial use like a brick refractory or an asphalt plant, something like that, that would be able to use it. The landfill gas basically is about 50% methane, about 45% carbon dioxide, and about 5% of the other contaminants. Nitrogen, sulfur dioxide, nitrogen, etc. like that. The necessity to clean up the gas to make it more compatible for transportation rather than just burning it for heat effect has resulted in some of these figures. 1 gallon of gasoline is 125,000 BTU. 1,000 standard cubic feet of methane is 1 million BTU. And 1 cubic feet of methane is roughly 8 gallons of gasoline, which kind of puts it in perspective. The amount of landfill gas that escapes from a landfill or that is generated by a landfill that is decomposing can vary. Obviously, if there is trash that is like shingles from roofs, those don't decompose. If there is a lot of yard waste or a lot of paper or a lot of other examples of that kind of waste, plastic bottles don't waste that well, but they do decompose over time. Other types of containers the same way. But by and large, your landfill gas will be on the order of 3 to 4 million cubic feet a day for a small to medium-sized landfill. On a particular landfill that we worked on in Columbus, Ohio, it would generate roughly 6,000 standard cubic feet of gas per minute. And that would be equivalent to about 36,000 gallons, gas equivalent gallons per day, gasoline equivalent gallons per day of fuel. So there's a substantial amount of fuel capabilities that are there. Just R.E.A.L was a partner of mine, and they had the cleanup mechanism that I'll get to in a second. These were some numbers giving you an idea of the volumes of the liquid fuels. Motor gasoline, jet fuel, distillate, which would be your diesel, others which would be like butane or propane. If you clean up the landfill gas and it is 100% pure methane, as was an example before, you need to compress it to 3,600 pounds per square inch to make what we would call CNG. If you wanted to liquefy it, you would have to take it down to a minus 259 degrees Fahrenheit. It is much easier to transport LNG or liquid than it is for the compressed gas. Compressed gas is basically very useful for vehicles, smaller vehicles in the cities that do not put that much mileage per day on. Somebody like a Federal Express or a UPS, they're very appropriate for it. if you're long-haul drive trucks, it is easier to use LNG and burn it and get much more in the way of mileage. That was just what I was saying there. It's larger vehicles, greater range. Basically 1.9 gallons of LNG equals 1 gallon of diesel. It's very transportable, peak shaving, converted very easily into CNG by just letting it boil off. There is cleanup required, and there shouldn't be any nitrogen in the LNG. Compressed natural gas, the good parts are ambient temperature. It works at ambient temperature. There's less intense cleanup required for the CNG than there is for the LNG. It is pipeline quality gas, which means that it could be put into a transcontinental pipeline, and smaller vehicles are restricted range. Basically, the quality of the biogas has been an obstacle. There's not that much anymore. The distribution of the clean biomethane is improving as more and more landfills are cleaning up and utilizing their gas. And this is primarily to fuel the trash trucks that reside at the landfill. And with engine manufacturers coming on and extending the warranties for using CNG and or LNG, that has made the equipment people much easier to work with. As I started out saying, the major components of landfill gas are methane, 45 to 50%, carbon dioxide, 35 to 40%. Nitrogen can vary between 0 and 15%, which is basically the as air is sucked in through the cover, it is in the landfill space. Oxygen and water, your contaminants, which are the things that we want to get out, are hydrocarbons, chlorine from freon and methyl chlorides, sulfurs, and silicon. Basically, it kind of goes through how you get to your transportation fuels. And as we said, it's a liquefaction of the pure methane and or the compression of the methane to CNG. To give you an idea, I attended a conference up in Baltimore 2 weeks ago. It's the Landfill Methane Outreach Program of the EPA. And they promote the utilization of the landfill gas, that instead of flaring it and basically wasting it, to utilize it either for transportation fuels such as CNG or LNG, production of chemicals like methanol, for wastewater treatment and other uses, for pipeline gas, which is considered to be renewable, since landfill gas has been designated as a renewable resource. There are somewhere around 1,400 to 1,500 landfills that have gas collection facilities in them, or installed in them. There's roughly 570 some odd operational landfill gas projects. So you can see we're about a third of the way there. There are a number of landfills that have potential. One down here on that I mentioned, waste management's at the Granite City exit on 5570. That is a major landfill. Currently there is no use of the gas. Another major landfill is the Old Fred Weber landfill, which is out on Interstate 70 and 270 in St. Louis County. Currently they are putting in an electric production utilizing waste gas from that landfill. There are 3 other landfills in the St. Louis area that are closed There are no projects on those at this time. We're working to try to put together some projects primarily for the trash truck refueling, as well as for production of pipeline gas.
Thank you, William.